It's 1960, and the MIT centennial is just around the corner. CBS notices this and decides to celebrate the occasion. They'll make a television program. They'll call it Tomorrow. It will be about the future that MIT scientists are working to create. This is Douglas T. Ross, professor at MIT. He's busy coining phrases like computer-aided design. And this is Thomas H. Wolfe, television producer at CBS. He's worked on shows like See It Now with Ed Murrow, but now he's writing and producing Tomorrow. Wolfe and Ross get lunch in New York. They're discussing whether computer-aided design would make for compelling television. Ross fears that it won't. It's too esoteric, he tells Wolfe. The mood goes dour, the lunch is almost over, but then Wolfe pops a wild question. Could a computer write a Western, he asks. The plots are so formulaic, he says. Could a computer write a Western? Ross thinks about this for the rest of the lunch and indeed for the rest of the month before finally writing back later with an answer. Yes, he says, but only if it's a pantomime, no dialogue. Wolfe remains enthused, and it would appear that a peculiar collaboration between CBS and MIT is underway. But then, Claude Shannon, for reasons I have not been able to determine, attempts to convince Wolfe not to go down this path. But ultimately, he is unsuccessful because this is CBS Televised computer-generated stories in 1960 and 10 million watched. I'm James Ryan. This work was done in collaboration with Gillian Smith, with special assistance from Don Knuth, Chris Garcia, the Computer History Museum, and MIT Archives and Special Collections. Special thanks also to Mark Sample and the Bang Bang Con 2020 organizers. Shout out to Liza Daly. No one had ever done anything quite like this before. In 1952, Christopher Strachey produced computer-generated love letters, and in 1959, Theo Lutz produced computer poetry in German. But this would be the most ambitious undertaking in computational media to this time. And Ross had to invent everything from scratch. His early sketches are remarkably well formed. Each story will take place in a hideout and center on a shootout between a robber and a sheriff. Characters will move about the world along 6 places of action: the corner, the table, the window, the door, the area outside the door, the area outside the window. Action will center on props: money bags, a bottle of whiskey, a glass, and of course, the guns. Each prop affords certain actions. You can pick up, put down, count, or gloat over the money. You can pick up, put down, pour, or drink from the bottle and glass. You can do gun things with the guns. You can do other things no matter what you're holding. This is Harrison R. Morse, aka DIT, graduate student at MIT. He's going to lead programming on this effort using the TXO computer. This is the legendary machine on which the original hackers, the Tech Model Railroad Club, are learning to compute at night. Morse is working in machine language, much of it macro-generated, and he's on a TV production schedule. He must deliver generated screenplays to CBS in 6 weeks, or the network will go ballistic. Source code does not survive for this program, but flowcharts do. Here's a segment that I've reconstructed for illustration here. It defines how the sheriff will act in the world at a high level. First, he enters the scene, then he goes to the window. Next, he calls the look routine, which has its own segment in the flowcharts. As a result of look, he may spot the robber, and the robber may spot him. From here, we proceed to what Morse calls a switch. This is a probabilistic branching point in the logic. It's what allows the program to produce unique stories each time it's run. To decide which way to branch, the program consults a scoring mechanism for that switch. This takes each of the possible branches and scores them according to the state that the world is in. Authors define these scoring mechanisms. As an example for this switch, if the sheriff has spotted the robber but not vice versa, the advance and other branches will be about 10 times more likely to be taken than the wait branch. Let's say we go this way. Now we've reached a different branch, but this time it's deterministic, based simply on what's in the robber's right hand. Let's say he's holding a gun, which means we proceed to another switch, which will have its own scoring mechanism. From here, let's say we go this way. Now we've reached the shoot routine, which will have its own segment in the flowchart. There's 3 of these flowchart leaves, which gives a sense of the size of the program, which Morse and Ross named SAGA II. Now, one peculiar thing about SAGA II is the level of detail with which certain actions are modeled. All of the logic you see here is simply so that a character can empty his hand of an object. Now, one cool thing about SAGA II is the authoring interface that Morse made, utilizing the Flexowriter online console at the TXO. In an authoring mode, whenever a switch is reached, control of the program is temporarily yielded to a human author sitting at the Flexowriter console. By typing into the console, the author can modulate any scoring mechanism for any switch, thereby changing how the stories look in real time. SAGA II is specifically a script generating program. As it's being executed, the Flexowriter prints out, line by line, a generated script. Here's an excerpt from a script that I found at the Computer History Museum. Now, Morse didn't have computer memory or time to devote to a natural language generation module, so he had to rely on a clever hack for actually producing the language. Here's how it worked. At any given time step t, the story world is in some state. Then the next action will occur, sending the world into its next state. Anytime this happens, SAGA II checks for the delta between these, and this delta is rendered in natural language as one line of script using simple rules. Right on time, 6 weeks later, Morse and Ross delivered 9 of these computer-generated scripts to CBS, along with Ross's sketches. CBS then built a physical set from the sketches and cast the talent. In the role of sheriff, Haywood Hale Brown, future sportscaster, and robber, played by Jack Gilford, future Oscar nominee. Gilford is particularly spectacular. Recall the level of detail with which object handling is modeled in SAGA II, and now watch Gilford's hands as he performs the generated lines, the bottom right. Notice the passing from left hand to right and back. Now, one interesting thing about SAGA II is that the more characters drink, the more erratic their behavior becomes. This is called the inebriation factor, and it affects nearly every scoring mechanism, producing interesting emergent narrative in some of the scripts. CBS produced 3 of the generated playlets, 2 of which are especially remarkable. In the second, the robber hits the sheriff, killing him before making off with the cash. To my knowledge, this is the first time in television history that a villain was victorious. This is because Wolfe did not believe that a machine could be held to the strictures of the Hays Commission or FCC regulations on what could be written for television. The third playlet is glitch art. CBS enacted a buggy run of SAGA II to humorous effect. In 1960, there were 3 television stations in the U.S. That Night Tomorrow aired on CBS against Peter Loves Mary and Naked City. It finished second in the ratings, with Nielsen estimating 7.7 million audience households, which allows us to safely assume that these computer-generated stories were watched by at least 10 million. The next day, newspapers ran sensationalistic headlines and an amazing illustration. The reviews were generally favorable, but one contingent was livid. At the end of the program, Thomas H. Wolfe is naturally given writing credit. But additionally, so is the MIT computer TXO. This incensed the Writers Guild of America, who demanded that CBS remove the computer's credit should the episode ever be re-aired. To my knowledge, it never aired again. This was CBS Televised Computer-Generated Stories in 1960 and 10 million watched. I'm James Ryan. You can find more of my historical work on Twitter at XFOML, and you can watch the generated playlets at tinyurl.com/saga-2. Thank you so much for watching.